Okay, the question is, the arm is pulled back. This arm, look, if you take a closer look, this arm is pulled back, and how far it has been pulled back by, like, stretch is, I would say delta S is equal to 100 millimeter is 0.1 meter. Let's convert it into 0.1. So it stores the potential energy. The spring stores the potential energy at location, suppose this is location A, and over here is this is location B, and the spring is unstretched when it comes back to this mean position, which is 0. This is my 0, this is my 0.1. And now assume all surfaces of contact to be smooth. That's good. So no friction involved, so I mean energy conservation principle is valid. And neglect the mass of the spring and size of the ball, and find the speed of the 3 kilogram. So the mass of the ball is 0.3 kilogram, and find the normal reaction. Look, this one you have to find out normal reaction of the guides to support the ball. Okay, that's what. And it has its weight. Look, another free body diagram, it has its weight at location B, so weight has to be. And do we have this angle? Angle is 60 degree. So let me draw it over here again. So if I grab this, again to draw the free body diagram to explain it to you again. So what are the forces acting on it? The force due to the gravity, force due to the guide. This one we have to find out at, look, imagine this is location B, this is location A, WB, it is 60 degree. And if you take a look, this is my x is normal unit vector, and this is my x is tangential unit vector. Agreed? So can you resolve this weight force into normal? The question states you have to find out the speed of the ball at location B, and you have to find out the normal reaction. And we know the energy conservation principle between the two positions, T sub A, big V sub B, big V sub A, big V sub A equals to T sub B, big V sub B. Okay, so now I'm going to draw the datum line passing through this position A. That will solve a lot of problems here. So initially it is at rest. Now the ball is at rest and it is released suddenly. So initial kinetic energy is 0. Initial potential energy, because it is passing through the datum line, so we have 0 potential energy. On the left hand side is all 0. The right hand side is, we have to find out, half m v sub b square, and the big V sub b is mg h sub b. So what is this? Look, this height, you have to take a look. This height is h sub b. So look at this one. What is this? This radius of curvature is 1.5. So can I take off this right angle triangle? This is 1.5 cosine 60. So I'm gonna write down h sub b equals to, and it is going up, so it is positive. That's correct. So m mass is 0.3 kilogram, gravity is 9.8. h sub b will be the difference of this curvature, radius of curvature, minus 1.5 cosine 60. This is this distance, this depth. Okay, this depth. So you can do the math easily, it's not difficult. So there is just let's apply this into our equation and find out what is the v sub b. That is my objective. So if you do the math here, the left hand side is 0, the right hand side is half times 0.5 times v sub b square, and plus everything over here, it will be here, big V sub b. So if you solve for this, you are just one unknown, v small v, velocity, one unknown, one equation, you get this answer. And the other thing they are asking about the normal force. So let me grab this again for your convenience. Look, I'm going to apply the same force, all the forces along the normal unit vector, they are equal to mass times acceleration in the normal direction, and acceleration normal v square over rho. V sub b is 5.94 square over rho. Rho is 1.5, so acceleration normal is it can be found. So now let's do the math for, look, this vector is nb, which is positive, and this vector component is wb, which is negative. So look, over here this angle is 60. What is this angle? Take a closer look. If this is 60, same line, vertical line is 60. And what is this angle? 30. 90 minus 3. So this side is WB sine 30. Do you agree with your professor? WB sine 30 equals to mass times acceleration. Mass is 0.3. Acceleration is, we already found it. So one unknown, one equation. So NB comes out to be 8.53 newtons. This is your answer.